All right, ladies and gentlemen, welcome to the lecture on tech and innovation in supply chain management. The agenda for today, we will talk a little bit about, what tech and innovation is relevant in supply chain management by first taking a little step back into history, and we talk about how we came from Industry 1.0 to Industry 4.0, the era that we're in nowadays. Then we talk about the various different technologies, big data, robotics, the Internet of Things, and also a core group of these technologies, namely visualizing technologies such as AR or VR. And we'll dive deeper into the augmented reality technologies, especially because that is my research background and that is a background where I can share my best with you guys. So we focus on AR for various SCM procedures. I will have a couple of examples lined up for you guys from various industries, supply chain applications in a warehouse or in a asset management process. And I have plenty of examples in the form of pictures, also videos, a few that we'll share with you. So you guys have a good overview of the current whereabouts in terms of smart technologies and new innovations in the area of supply chain management. Good. So let's talk about Industry 4.0 and smart technologies. So of course, there are plenty of technologies out there. I think the most important ones are currently listed on that slide. So we talked about big data and how to use big data to optimize supply chain management processes to optimally, serve the need of our customer in the end, because that is what is most important at the end of the day. Then we talk a little bit about robotics, how robotics is being used in supply chain management, particularly, of course, in logistics centers or warehouses. I think I mentioned that in one or some of the tutorials already. I try to stick to the term logistics centers because a warehouse, according to one of my old bosses at Zalando, a warehouse is where things stand around and not being moved around and get dusty. So we focus on robots in logistics centers. We talk a little bit about Internet of Things, and then the core of this session will be the focus on visualizing technologies, especially augmented reality and virtual reality. I will highlight the differences between the two and give a couple of examples on augmented reality in supply chain management in particular. Good. What do we have? Let's start with the 4 fundamental challenges that supply chain managers or people that work in supply chain face today. And these 4 challenges are cost, speed, accuracy, and agility. And a survey from McKinsey that asked various supply chain managers and C-levels in the supply chain industry, CPOs, the top goals of these supply chain managers were to reduce operating costs. It's still one of the most demanded goals from supply chain managers. 34% said they want to get products to the market faster, more efficiently, and consumers are also demanding faster delivery, such as even same-day delivery. Or if you take grocery online chains, for example, think about Rewe Digital, the German supermarket chain that's trying to digitize the supermarket industry, where Tassilo Kramer from last week's lecture used to work for a while. They're really planning on same-day delivery where customers can actually pick delivery windows of 1 or 2 hours. Another top goal was to improve service level. Almost a third of all the managers said improving service level is crucial. It's a crucial challenge nowadays for supply chain managers. And 16% said it's important to reduce risks in supply chains, reduce volatility, especially demand volatility, and kind of safeguard your supply chain against disruptions. So how can we tackle these challenges? Well, technology and new innovations are usually a way on how to approach these challenges and ensure that we can reduce costs, increase speed, accuracy, and agility. Let's talk about the different industries. So when I was working at Zalando, it was still in this decade, 2012, 2013, 2014. I would say we were at the very end of Industry 3.0, maybe already approaching Industry 4.0. And the big topics back then, so let's say for the sake of oversimplification, about 10 years ago, a decade ago, in supply chain management and in logistics centers, it was all about automated storage and automated retrieval systems in warehouses. So how can technology reduce costs in logistics centers? How could we make logistics centers more efficient by having, automated conveyor belt systems, automated picking techniques, and reduce one of the biggest costs in warehouses, which is still the personnel and it also was about enterprise resource planning, so managing your demand and supply, making sure the right logistics center has the right articles, clothes, shoes, whatever Zalando was selling at the right point. and making sure that the transport between the warehouses managed with an EDI, an electronic data interchange system. Again, a little example about Zalando. So at the time of when I was working at Zalando, Zalando had 3 main logistics centers in Germany. There was one in Berlin, one in Erfurt, and one very close to Venlo, actually in Mönchengladbach. And these 3 warehouses weren't exactly the same. So one warehouse stored mainly male items, the other warehouse stored mainly female items. And the reason behind that was that some smart guys from business analytics had figured out that storage of items that have a higher likelihood to be ordered together at one location makes more sense than storing the whole portfolio of products across all 3 logistics centers equally. So imagine what a customer does. There's a male or female customer comes to the web page, and there's a high likelihood that this female customer will order 1 or 2 or 3 items from the female category, right? So this would reduce the need to ship items from one logistics center in Erfurt to a logistics center in Mönchengladbach and only then send it out to the customer. So this was all done by enterprise resource planning systems and electronic data interchange, just to give you a quick example from Zalando again. But let's dive a bit into how we actually came from industry 1.0 to 4.0, and also why do we have those different names for different industries, right? So we start back at the Industrial Revolution, which was approximately almost 250 years ago. 784, we started with the invention of steam machines. We have a lot of weaving looms going on and the mechanization of the industry. So industry 1.0 is what we call the Industrial Revolution, right? Then about 100 years later, the Industrial Revolution had moved on, and we had the development of mass production, assembly lines, and electrical engineering that kind of got or replaced steam engines. Then Industry 3.0, as I said, started in the 70s, and with the introduction of computers and also the internet later on in the 90s, we had further automation in logistics centers and in the industry as a whole. Computers and electronics helped with the electronic data exchanges, and a new kind of revolution in industrial production was born. Nowadays, since 2010, 2015, depending on where you want to set the exact starting date, we have more technology, we have better ways to interact with and or analyze huge amounts of data. We have very quick ways of letting logistics centers communicate within each other, but also with each other. And with the Internet of Things, we can link various production lines or robots or even whole logistics centers to each other to get a better understanding of where our demand is coming from, when our demand will be what at a certain point of time in a year or in a day, and we can also manage our supply better. So with Industry 4.0, we marry the advanced production techniques with really smart digital technologies. And that creates kind of an interconnected enterprise, an interconnected digital enterprise, if you will, that can almost work in some cases autonomously without the help of, human interference. And in Industry 4.0, we communicate with data, and we analyze and use data to further drive intelligent action back into the physical world, meaning we take the learnings from data and from data that we analyze in a meaningful way and assess the learnings often in real time to improve processes in our supply chain. Now, as I said, let's talk a little bit about these 4 or 5 different smart technologies that we have within Industry 4.0. I know there are also other ones, we can make a whole lecture about blockchain, for example, in supply chain management as well. I think these 5 ones are the most relevant ones, and this is also shown in research. Blockchain is always a big buzzword. Yes, it can be used to, make your supply chains more secure and or more transparent, but that is often where current application on a large scale already stop. So let's dive into these 5 technologies that are listed here. If you see AR and VR as different technologies. Everyone probably knows this guy, the head of Amazon, Jeff Bezos. He was one of the first persons, or his company, Amazon specifically, that focused on big data in a supply chain specific context, right? So Amazon really focuses on the advantages of different algorithms for automation. Amazon was one of the first companies that had their own data warehouses with computing power to actually process a huge amount of data. And Amazon also used machine learning to train algorithms to automate more processes on their website. So Amazon came up, for example, with the concept of anticipatory shipping. So what Amazon does here is it's analyzing the real-time behavior of customers on the web page, and it's used real-time analytics to ship the correct products from the correct warehouses in a very quick and agile way to their customers. So this was unique. Nowadays, some more companies are able to implement that, but Amazon was really one of the first companies applying that. And that was revolutionary because, this is similar to, supply of public goods. Like, let's say, for example, take water or electricity, which is a public good, right? Their supply is always constantly provided in anticipation of your demand, right? So public goods, if you open the faucet in your sink, water will come out, right? So supply is always there, and whenever you demand it, it's coming out of the faucet. Amazon was trying to mimic something similar. Of course, there's little delay. It's only shipping it when the customer orders. But the idea behind the big data analytics was, while the customer is still browsing on the web page, in the warehouse, the package is already assembled, because the data can forecast if the customer will actually click on ordering or not. So the delay of actually starting a shipment is drastically minimized using big data analytics. The next topic is robotics, right? So robotics is a crucial topic, especially in logistics centers. There are a couple of companies, big companies, working on robotics for logistic companies, so ABB, QK, or Fanyuk. And we all know that robots don't all look like R2-D2 from Star Wars. Just to give you a bit of an idea of how big the robotics market is. So robotics can crucially influence the whole e-commerce sales, right? And behind every e-commerce sales, there's usually some sort of logistics center, even if it's a small logistics center somewhere. And the whole e-commerce market worldwide is almost to be forecasted to be 2,000 trillion US dollars already in 2016. So it's a huge market to be impacted. And nowadays, still 80% of warehouses are just manually operated. So there's a huge impact to implement robotics and to automate warehouses. Only 20% of warehouses or 20% of logistics centers operations nowadays are actually automated, right? There's still a huge majority of tasks that are manual. And just for example, in the next 15 years, BCG forecasted that there will be a shortage of 10 million employees, especially for warehouse and logistic center tasks, also transportation tasks like delivery and last mile delivery, only in Germany, right? So there will be a huge shortage of workers. So there's also a crucial need to further dive into robotics and understand how robotics can help us to improve logistics centers. Again, we are sticking to the Amazon example. So Amazon developed this orange robot that you see here on the slides called the Kiva robot. And that was a robot that could actually drive shelves through the warehouse, and the whole warehouse suddenly became a modular warehouse. And Amazon currently has about 15,000 robots working in the warehouses. So it's a huge number of robots. And these robots can help to drastically cut costs through automation. And they also allow for this flexible warehousing layout that you see here, where the robots can actually move the shelves from one point to another. And that, again, helps to reduce costs and agility. The next topic that I want to talk about is the Internet of Things. Here, we first need to understand what is the Internet of Things, right? So first, the Internet of Things started basically with the development of the barcode. Right? The barcode is one of the oldest, or simplest forms of the Internet of Things, because it allowed us to connect movements of an object with data, right? Wherever this barcode was, it was scanned and a data point is generated. And this data then helped us to track the movement of a parcel or the movement of an article within a warehouse, but also across warehouses. So barcodes were the first thing that actually also made parcel delivery more digital and allowed even tracing of parcels, which 30, 40 years back wasn't possible. Then we moved on to RFID, which are being used a lot as well to track parcels in real time, especially overseas parcels or containers, even overseas shipments. And nowadays we move more towards more data-driven services, such as sensor networks that can tell you in real time where things are moving. And these things can be any products in your logistics centers, or can be the fleet of trucks or ships or airplanes that you as a company own. And the Internet of Things is really helping us to track our fleet and our products in real time which allows for further optimization and for further, cost reductions or for further agility. So, in a typical logistics center, for example, there could be so many sensors that link together various things. So sensors could tell your employees that there's a dangerous or hazardous object ahead in a forklift, for example. The objects on a forklift, could, for example, also warn the forklift driver, hey, there are employees running around. In the same time, we always know where our employees are working at the moment. We know where our goods and items are. And all these things are connected via sensors and linked together with the Internet of Things. This again has a positive impact on speed, accuracy, and agility of our logistics operations. And last but not least, and this will take a bit longer now, let's talk about the visualizing technologies and how they can impact our supply chains. So first, we need to investigate what are these emerging visualizing technologies and how do they differ, right? So the emerging visualizing technologies are technologies that virtually visualize information. And information can be anything that you can see, right? That can be visualized. And both virtual and augmented reality haven't really been adopted by the broader masses, and therefore it's an emerging and crucial research topic that is very relevant for supply chain managers to understand, because there are huge efficiency gains to be made with both of these technologies in various different fields. But let me first explain what these differences are. So a researcher in 1997 with the name of Azuma came up with the virtual physical continuum. Okay, so what we're saying here is on the left-hand side, we have the physical, and on the right-hand side, we have the virtual world. And we all know our TV screens, laptop screens, iPhone screens, they're more on the physical side. Then in the middle, we have augmented reality that mixes virtual content, but in the realm of your real world. So you can steal the real world and you add virtual content to it. And then on the very right-hand side, we have the virtual reality, where you're completely immersed into a virtual or digital, if you want, environment, and you don't really see or interact with your physical reality anymore. Good. Then let's start with augmented reality. So there was a smart guy with a name that I will give away in a second, who said every organization needs an augmented reality strategy, and that was about 3-4 years back. And recently he also said AR is a technology whose time has come. This particular person is called Michael Porter, the founding father of marketing, but he also does a big deal of research on supply chain management and also especially employees in logistics centers. So if one of these guys thinks augmented reality then is important, then it's worth to investigate what this technology actually is all about. So augmented reality, we have seen that a lot on the very end of the supply chain, namely on the consumer end of your supply chain, right? So I'll give you a few examples. We have augmented reality in online shops such as Mr. Specs, which is an online eyewear retailer in Germany. Think of similar to Ray-Ban or other companies selling eyewear, and they give you something that's called a magic mirror, I think, where you film yourself with your webcam on your laptop turned on, and you can try on the glasses, sunglasses or normal glasses, right on your face, and they're projected on your face. Think of a Snapchat filter or an Instagram filter that does the same for you. Other companies that have adapted similar virtual try-on methods, L'Oreal or other makeup companies. So there's plenty of apps that you can download and you can try out makeup virtually, but just filming yourself and trying out makeup. So that would be all the fashion or makeup industry that's using it a lot at the consumer end. And we will talk about the supply chain related factors as well. We have IKEA or any kind of furniture retailers that are selling furniture to an end customer, and they have applications where you can project furniture into your living room so you can try out how it would look like, how it matches with your existing furniture. And this leads to the fact that customers are more likely to actually especially purchase from home as well. Last but not least, you all probably remember the Pokemon Go game that went quite viral. I think in the summer of 2016 that was one of the first games that highlighted, augmented reality and showed that people were actually chasing virtual objects or digital objects in the form of augmented reality, and we're actually spending a lot of time and effort to chase those AR objects. Now, let's talk a little bit about what augmented reality actually is. So the important thing to note is that compared to VR, AR, so augmented reality, combines the physical, the real world, if you want, with virtual objects. These virtual objects can be called holograms. If you want, they're not the same as the holograms back in Star Wars, right? You still need a screen to see them, but for the sake of for the better explanation, I'll refer to them as holograms. What happens is that the cameras of smartphones, of augmented reality glasses, they register physical and virtual objects, and they sync them in the way that these holograms appear to be realistically sitting on a plane, like sitting on a table or sitting on a chair or sitting on a roof or on the floor. And important also with augmented reality is that it runs interactively. That means often you can resize or rotate or move these holograms around. And this all happens in real time as well, right? So it's not uploading a picture and then 2 minutes later you get a picture that shows you how you would look like in a different dress or something, but it happens in real time. You look on the screen and immediately you see how a certain lipstick would look on your lips or how a certain pair of sunglasses would look on your face. But that's the concept of AR. There are 3 different types of devices. So we have the handheld portable devices such as phones or tablets, and really every phone nowadays is able to project holograms into the world, which is really important because it means all consumers basically have access to AR devices. Then there are desktop applications that are being used with your webcam of your laptop or of your stationary computer. And then more advanced, there are wearables such as AR glasses. These aren't really accessible by consumers so much yet because they lie in the price range of 2,000 to 5,000 euros, depending on which glasses you look at. But they become really important for supply chains because they're being used within business contexts, because companies can afford these sums if the AR glasses actually benefit them in improving efficiency within a warehouse, let's say. Now, virtual reality, I have a quote from another very famous guy called Mark Zuckerberg. You all know him as well from this little social network that he founded. He said that the incredible thing about virtual reality is that you feel like you're actually present in another place with other people. People who try it say it's different from anything they've ever experienced in their life. So in virtual reality, the difference to AR is basically that you're completely immersed, completely gone from the physical world, but you're standing visually at least in a 360-degree artificial or virtual environment. And often you can, interact in this virtual environment by moving your head around and looking around. Some virtual reality glasses also allow you to use some sort of controllers to interact in this virtual world. And you can also interact with other people in a virtual environment, but this interaction only really happens in a virtual environment, not compared to AR, where you both maybe stand in the same room and look at a hologram, but the interaction then happens in a physical world, right? For AR. For virtual reality, you're completely in the virtual environment. The devices, there are also 3 types, or we can cluster them as 3 types. We have VR glasses for your smartphone. These are the more easier, simpler device where you put your smartphone in some sort of head-worn device, and you can use that to watch like 180 degrees or 360 degrees videos, but you can't really interact in those. Besides of moving your head around, you can't do much with them. Then there are VR glasses for computers. There you usually get some handheld controllers and you can actually click on things and move things around as well. These are a bit more advanced. And the most advanced devices, are VR platforms. They're mainly used at the moment in the gaming industry, but also actually in healthcare for recovery of, stroke patients, for example, where virtual environments where you can walk on VR platforms, you can actually walk through real VR worlds and you move forward by actually moving your feet. Good. Then the pros and cons from a user perspective of AR and VR. All right, so pros and cons from a user perspective. The AR glasses or AR devices, especially smartphones, have the advantage of being widely available, right? So it's not a technology that needs to be brought to the market, but it's available for a lot of consumers and employees in the supply chain as well. AR really helps you to modify an existing service or context by augmenting it with additional information, and is applicable in almost every industry and service context. Virtual reality has the advantage that, you can create whole new worlds, and you can also let people do a task repeatedly in the same world. Think about training for employees, right? An employee at Zalando needs to go to various training before he can be working in the warehouse, and they need a physical location where employees can learn how to pick and stow items in a warehouse. You can do all of that virtually now, and then always just click on restart and think about it like a level in a computer game, and let the employee do that 20 times until the employee doesn't do any mistakes anymore. And then you can actually take the employee and put him in the real warehouse or real logistics center and let him do the task there. Virtual reality also, can create future or past experiences, and it can also replace physical experiences or make 2D experiences more lively. For example, Zoom calls would probably be way better if we all had VR glasses. That cons for both technologies. With AR, there are often privacy concerns because at the end of the day, you always point a camera at something or some person or some environment, and the head-worn devices, AR glasses, are not widely accepted yet. This is less an issue for SCM per se than for the end user. And virtual reality, the devices are still far away from being adopted, so none of the consumers have it, and its applicability to supply chain contexts is a bit limited because you can do it for training, yes, but training is only a small part of improving aspects of your supply chain. The majority of improvements can probably be found in the actual processes that happen in a logistics center or that happen in a supply chain as a whole. Good, now let's dive deeper into augmented reality for supply chain management. So one example, and I'll give a couple of examples now. So one example could simply be that augmented reality can deliver digital information, for example, a step-by-step plan for a fault diagnosis. Okay, so think about any machine that needs to be repaired. Usually you have an employee that goes to the machine. The employee either knows it by heart or has like a user manual and looks at the user manual, which part of the machine he has to fix, which screw to unscrew, which pipe to change, which cable to change, and so on. So with augmented reality, as you see here on the picture, imagine a worker that wears AR glasses, and immediately he gets visual information of which pipe to change or what to do in a certain situation, which allows the worker to be hand-free, more flexible, and the probability of errors can also be reduced. Another example is that AR allows for image recognition, right? So the glasses, and you see an example here from a car manufacturer, can show the worker exactly where he should assemble certain parts of a product, such as a car. It can also show the worker if the worker has a right door in the hand right now, because the camera that's in the front of the HoloLens can just recognize the color of the door is the right one, the shape of the door is the right one, and that can significantly improve manufacturing processes, but also especially reduce error rates that still happen with employees. Then we also can use augmented reality for remote assessment. So what you see on the right-hand side, there is a maintenance worker on a windmill, for example, and at somewhere else at a different location, we have an engineer, and the engineer can type and draw actually on the screen, and the worker sees that and knows immediately what to do. So that could help in reducing costs, because you only need to have one engineer to monitor, let's say, 10 other repair workers. Then we also look at video images for remote assessment that we had, and then the annotations in a warehouse, in a logistics center. So what you see here is a worker with an AR glasses. The AR glasses scan the barcode for him, what the worker usually would do with a handheld scanner, and that helps the employee to immediately know what item to pick and where to put it. Then we also look at embodied interaction. So traditionally, workers in SCM processes or in logistics centers really rely on physical objects and controls. But with augmented reality, we have this whole new user interface where we can simulate physical control. And every supply chain probably starts with some sort of prototyping, right? Before you know what kind of products you want to buy or build or source, you develop products by doing prototyping. And prototyping can now be done in augmented reality because it can help you to design a product, ship a 3D model, send it across the world, let another team design it, and you can use hand gestures to manipulate 3D objects. You can see that on the left-hand side, where Volvo is trying out augmented reality glasses for prototyping to improve the prototyping processes that they have. AR also extends the abilities right? So AR overcomes this problem of self or social scaffolding, which is a theory that describes basically if a person wants to solve a problem or enables a person to solve a problem, if this person goes beyond his unassisted efforts. And usually people get stuck there because they don't know how to solve a certain problem, and then they stop with problem solving tasks, right? But what you see here on the two pictures is that, for example, Boeing uses AR glasses to extend the abilities of the worker by offering AR-based trainings. So the AR training runs the employee through the 50 steps of assembling an aircraft wing, and this helped to reduce the time to assemble an aircraft wing by 35%, and people without any prior knowledge on how to assemble the Boeing aircraft wing has succeeded using this AR training in 90% of the times. Then on the right-hand side of the screen, you see ThyssenKrupp is piloting as well remote maintenance support, where you could wear augmented reality glasses. In this case, it's a Microsoft HoloLens 1 that you see here. You can use it in a private context, but ThyssenKrupp is using it as a remote maintenance support context, where if customers don't know how to, let's say, change a pipe from their sink, they could call a remote assistance person, and this person draws on an iPad or on a screen, and you would see exactly where to unscrew a certain pipe or a screw. Here in this example, it's, I think, for marketing purposes, it's a daughter calling her dad, and the dad helps her to, change a certain part of the sink. Good. So augmented reality has these unique features. It puts visualizations into your real world, into your real environment, bodied interaction, so you can touch and not touch, but you can virtually touch these holograms and move them around. Of course, you don't have an actual haptic feedback yet, even though there's also prototypes going on about gloves where you actually feel pressure if you touch holograms, and it extends abilities of our workers. Now, I'll have a little video here for you. I hope that loads sufficiently in this online lecture. Also from ThyssenKrupp. Let's quickly look at that.
It's all about dispatching a service technician using HoloLens in very different kinds of ways. So as soon as the technician puts on his HoloLens, he sees, I have a call, I need to go to this elevator. Then he sees a 3D picture of the elevator that he's going to work on. He can zoom into a part that also offers training opportunities. One of the major advantages of the HoloLens is that the service technician arrives at the job site better prepared than ever before, because he has the relevant data available in the best format possible, and in a variety of ways he can tailor the data towards his needs. As soon as the technician puts on his HoloLens and looks at the elevator, he sees the historical notes first, telling him what has actually happened with this elevator before. This way, he has all relevant information right there without having to look at it, saving a lot of time, stress, and effort. On his virtual desktop, he gets all necessary information about the task orders he has to carry out with the latest safety alerts for that elevator. He pulls on a 3D, the replication of that part, then he changes into an exploded view so that he can actually see which part is causing the problem. Completely new and a major advantage of the HoloLens is that the technician is hands-free. One of the most important capabilities with HoloLens is to trigger a remote call to a subject matter expert.
Call Heather.
Hey Jeff, how you doing?
I'm replacing a doorboard out here, but I kind of want you to check a couple things out.
Okay, let me take a look. Your JP3 is in the right position and your motor leads are disconnected, so you're good to go.
The result, time saving and less stress for the technician. Tests have shown an enormous potential to increase productivity. A job that used to take up to 2 hours, ending up with the necessity of the expert traveling to the site, can now be carried out on the first visit in less than 20 minutes. We at ThyssenKrupp Elevator are constantly striving to develop new technologies to meet the challenges of urbanization and build the cities of tomorrow.
All right. Of course, this is a marketing video, so take that into account. Microsoft actually did a lot of those with different companies. But the point is that augmented reality really comes in at various steps in your supply chain, right? It can come in the planning process, and later on we see how it also comes into the make process, delivery and return process. So the planning process, again, It can start really with product development and prototyping. We talked a lot about Volkswagen last week. Now maybe also a positive example about Volkswagen. So augmented reality can really help to create a shared reality and support collaborative designs between prototypers. And remember, we also talked about coming up with prototypes from suppliers and buyers together. So it could also be used in supplier-buyer communications. At the bottom right, you see a nice example where the augmented reality just helps to also imagine different colors real quick. With a click of the button, you can simply recolor a whole car or a whole prototype of a car or a product. And augmented reality, you can have a physical car designed, but if you quickly want to change the color, that's also where AR can come in, and we call that a match between digital and physical mashups. Then we also come in at the make stage, and here we have this Volvo example where in manufacturing processes, AR really helps you to improve your efficiencies. Other examples where it's actually being used quite regularly is in the airline industry. Boeing, Airbus, for example, they have these huge circuit boards, so electronic boards that are part of an airplane. And on each board, there are like 100 cables that need to go from one side to the other in a certain way. So the whole electronics in the airplane later on work as intended. And with AR, the employees that assemble these circuit boards, they know exactly which wire and which cable they have to put in where. And using these AR glasses in the assembly task has drastically helped these airplane companies as well to reduce the error rate. Again, we also have it in the maintenance stage. So you could say that's actually an after-sales process, right? Could also be used in maintenance for your own logistics centers, maintenance of the machines there. So you see an example here from Bosch, where you basically have an augmented reality kind of after sales menu that helps customers or also engineers to repair car engines, but it could be applied to any kind of engines or any kind of machines in any kind of logistic processes. And there has been a few studies have been done already, but it's still an emerging stage. And these studies have shown that using AR in the maintenance industry can help to reduce processing times, but also errors especially. It reduces the cognitive load of workers. So workers are not that stressed and they're not cognitively that overloaded, which in the long run makes the worker more happy as well, because it helps to put information, especially 3D information or spatial information, into context. And often this is where traditional printed 2D manuals fail, because here you can immediately see what parts you have to change or what parts you have to check, for example, as a worker. Then also we have the delivery or return phase. Again, we have after-sales services like the example with ThyssenKrupp, where an elevator needs to be repaired, but also what you see on the right-hand side, that's actually an example from a bank in Australia. I actually worked together with this bank as a PhD student in Australia. So they just came up with this idea of having a little fox showing customers where the next ATM is. So it's more was a customer-facing application, but the same type of application can be used and is being used by warehouse workers or logistics centers, and also delivery people to improve navigation within logistics centers, speed up hands-free navigation. Imagine a kind of application like that on augmented reality glasses, where people follow some arrows through the warehouse and immediately know where they need to go while having the hands-free. So AR really works in the supply chain on the customer end, but also in manufacturing, navigation, and delivery processes. And then in after-sales services, we've also seen tremendous increases by some companies. Of course, I'll pick a lot of examples where you see, positive results of augmented reality. But all these examples are really just by innovative companies that decided to take the first leap to try out the technology and work on the technology. So we have data here from KPN and Xerox, where, in after-sales services, field engineers got, historic data, diagnostics, and location-based information on AR glasses, and it helped them to, reduce overall costs by about 11%, decrease error rates, increase the probability that the engineer only had to come there once to fix a certain problem, which reduced travel time and costs associated with that, meaning also that the engineer was able to fix another problem at a different location. The time was reduced to fix an after-sales problem, and it also increased customer satisfaction rates. Last but not least, we talk about really logistics center processes such as order picking. order picking, as most of you probably know, is simply the process of an employee going to one location, finding a certain item in a shelf, taking this item out of the shelf and adding it to an order, or mixing it up with different items and then shipping it off. So traditionally, we had the pick by paper process, right? So an employee has a list, goes through the warehouse, and on the list it says, hey, go to aisle 17, shelf B, and pick item number 7. So that's a traditional process. Then nowadays we mostly have pick by scan. So the employee has a scanner. The scanner tells the employee the same thing as a paper list did, and the employee scans the item wherever he is, so to ensure that we can track the item across the warehouse. And nowadays we also have pick by voice and pick by vision. AR obviously comes in the pick by vision process, so it shows the employee right away which item the employee has to pick out of a certain shelf or a certain location in the warehouse, and it's being trialed by various companies, the big ones that we all know, DHL, Ricoh, and they're already using that for various different logistics processes in larger and smaller warehouse operations. I have another video as well that shows how Coca-Cola is employing it. Look at that. So you see here the advantage is hands-free operation. So the operator can drive a forklift and still, execute certain commands with the augmented reality glasses. All right. Again, there are plenty of examples out there, but most efficiency gains are probably be done within the logistics center area. Last but not least, of course, I'm not saying augmented reality is a solution to everything, right? Of course, there's some pitfalls with regard to the technology, but I also would like to discuss some potential solutions for these pitfalls. So one big pitfall is, of course, technological limitations. Not all warehouses have steady and high-speed Wi-Fi connection, which you would need to send this huge amounts of data across from the glasses to a processing computer. These holograms are rendered information of pictures or digital content, so actually you would need a decent Wi-Fi connection within your warehouses. One opportunity or one potential solution to overcome this problem is to understand before a company starts to implement AR in their warehouses, to understand what they actually want to achieve with that and define a clear use case. That is always what we recommend in our research group, companies that come to us and ask us, hey, is AR something for my specific company or not? Then another pitfall is obviously still also the cost per piece. The Microsoft HoloLens 1 that you saw in a couple of videos or pictures is about 3,000 euros nowadays. Microsoft HoloLens 2, which came out this year, it sits at around 4,500 euros. So you need a lot of cost savings to, buy a couple of those for your. So it really has to be clear what the return on investment for these AR glasses is if you implement them in your warehouse. So before you start piloting, you need to have either a few consultants or some smart people in your own organization to estimate the return on investment. How much time could we save using AR glasses? What would be the reduction in error rates, and quantify whether that would justify implementing AR in your supply chain or in your logistics operations. And last but not least, there are also privacy and security concerns from employees as well, because you're constantly filming your environment. Employees feel, and we tested that in an experiment actually, employees feel kind of more monitored than they already are. So that is also something that you need to take into account if you want to implement AR within your company. You need to openly communicate toward your employees what the glasses are doing, if the data is stored somewhere or not, to ensure that the augmented reality implementation is actually successful for your logistics center or for your overall supply chain. Last but not least, some references and links. I mean, I think I've showed that before. I'm part of this research group. That is also why this lecture particularly focuses on augmented reality. And that was the lecture for this particular week, and I'll see you in a bit. Thank you, guys.